Hello everyone. Welcome to the mechanics of materials. And this video, we just raised one example for a force and moment calculation in 3D space. Okay, and this time is the example 3.4 from the textbook. Yeah, it's a very typical question. It's just there's a pipe hanging on the wall, okay, and we apply two forces on this pipe, and then this problem want to determine the resultant moment. Okay, determine resultant moment. Okay, so and then express this resultant moment in Cartesian vectors. Okay, so in this system we have two force, force one and force two. Okay, so let's start it. So you want to in one part problem one else calculate the resultant moment. Okay, so the resultant moment, just add the moment in this system. We have two forces, so we have two moment caused by these two forces. Okay, so the next thing is we have to figure out what's the moment one and moment two. Okay, and the moment one, okay, equal to r cross force one, and moment two, okay, is position vector cross f2. Okay. Okay, so force one, force two. This problem already give you the force vector information. So it's okay, it's very good. And next thing is what is the position vector of these two moments. Okay, what is this R? Okay, it's very important. Okay, for such problem, it's very important to find the correct position vectors. So okay, let's look at this picture. Okay, the reference point is O. Okay, this is a reference point for us to calculate reference point for the moment calculation. So okay, the force is acting here, the force one is acting here. So the simple choice of the position vector for force one is this one. Okay, this is R. Let's say it's R. It's point A. So let's say it's RA. Okay. Okay, RA is here. Okay. So the other is the force 2. Force 2 is in this direction. Okay, and then we want to calculate the moment caused by the force with respect to the origin O. Okay, so the natural choice, because the force is acting here, so the very natural choice of the position vector is here, and it's the B point. Let's call it RB. Okay. Yeah, for this system, we'll calculate the moment with respect to the point O. The very natural choice of RA vector and RB vector is are these two. Okay. So the next question is what is RA and RB? Okay, what is RA and RB? Okay, and then this problem already give you a coordinate. Okay, the origin is here. So these two position vector, they are based on this origin. So we just need to know, if we want to calculate the position vector, RA position vector, we just need to know the coordinate of A. Okay, so what is the coordinate of A? And what is the similarly, what is the coordinate of B? So coordinate of A, okay, be careful, XYZ axis. X is here, Y is here, Z is here. So in the point A, X is 0 and Y looks like it's 2.5 and Z looks like it's 0. Okay, and next one is B. What's the coordinate of B? For example, this is x is 2, x is 2. Okay, y is here. Be careful. Y is this. Y x is here. So y is 2.5. Same. And what about Z? Z is here. Z is here. Okay, it's 1. Okay, but be careful. It's below 0. 0 is here. 0 of z is here, so it's below 0, so it's -1. So okay, it's all relative to the origin, so the position vector A is 0I plus 2.5j plus 0k, and the position vector B is 2I plus 2.5j minus 1k. Okay, okay. Yeah, all have, so we found a position vector A and B. So okay, so we can calculate the moment one and moment two. Okay, so the moment one, okay, if you have and then don't forget the moment calculation 3D space, you can write it in a very condensed form, 3 by 3 determinant. 3 by 3 determinant. And the second row is position vector. Right? M1 is position vector of A. So it's 0, 0, 2.5. And RB is 2, 2.5 minus 1. And what's the force vector 1? Minus 600, 400, 200. So it's 800. Here is 400 minus 300. Okay. And next thing we have to do the expansion of the 3 by 3 determinant. So let me change to this color. So we can also I, yeah, maybe I write here. Okay, I then minus j plus sorry. No. I j plus k. So this one is I, then minus j, 2 by 2 determinant plus k, 2 by 2 determinant. So for the I, okay, we'll block this element, it will have 2.50, 400, 200. Okay, minus j, okay, block this two element. Very good. I think this must be 0 after all. And k, okay, block this element, so it's 0, 2.5 minus 600, 400. Okay, and M2, so let's do the same thing, block this element. Okay, 2.5 minus 1, 400 minus 300. This 2, 800 minus 1 minus 300. And the final one is 2, 800, 2.5, 400. Oh, it's very annoying. Okay. Okay, so let's see. For M1 is okay, 2 by 2 matrix, 2 by 2, 2 by 2 determinant. So this will be, yeah, this 500I. So this is 0 plus 0J plus K. K is, this is minus, so it's 1500. So 1500K. Okay, that's it. And the next release one is this one M2 is, let's see, okay, minus 750 and plus 400. Really? Mhm. Looks like okay. 750. Okay. Do I miss something here? Okay, is this right? Okay, minus 50I. Okay. Okay, so it's plus 400. Okay, minus 350I. So it's minus 600 plus 800. So it's minus 200J. Okay, let me check. Okay, so the final one is 800 minus 2000, I think. So it's minus 100 to 1200K. Okay, so let's add this moment two together because we want the M1, because we want the resultant moment M1, M2, add M1, M2 vector together. So this will become 150I, and this 0 minus 20, 0 minus 200, and the last one is 1500 plus 1200, minus 1200, so it's 300K. Okay, this is resultant moment expressed by Cartesian vector. Let me check the answers. Yeah, it's correct. Okay, so this is the example for the moment for the 3D moment calculation in 3D space. Okay, so okay, this probably yeah, it's not that difficult, but just be careful like doing the calculations. Okay, the force vector. Okay, give you this problem, give you a force vector, and then the next thing is the thing the kind of difficult part is to find a suitable position vector of in this system. Okay, especially for each force you need to figure out what's the correct position vectors. Okay, and then that's the most that's the most critical part for such problem. Okay, and in the PowerPoint I have other some other I have to switch this off. Okay, if you want to look at this detail, just please rewind. Okay, I have to temporarily close this off. And in the PowerPoint, I also give you three other very simple examples of how to determine a moment about point P in the 3D space. Yeah, for such problem, yeah, this problem all give you a force vectors. Okay, and you want to calculate the force, the moment caused by the force, and with respect to P. Okay, so the position vector. Okay, you have to be careful the position vector of this problem. Okay, so I just give you the hint of the position vector, and I won't do any calculation. Yeah, I just give you the hint the position vector, and then and then you will do remaining calculation or find the position vector. Okay, so it said the force is here, and sorry, I start from first one. Okay, this quick video. Okay, let's quick give you the hint of the position vector. Okay, for such problem, force vector is here, and you want the reference point is P. So the natural choice of position vector is P from P to the force, for P to this point. Okay, okay, because the force is acting on this point, and you want to calculate the moment caused by the force. Natural choice position vector is P, P to the force. Okay, so this is here is your position vector R, and you know the coordinate here, and you know the coordinate here, so you will get a position vector. Okay. Okay, that's so okay. The next problem, okay, same thing. He give you the force vector here, and you want to calculate the moment with respect to P. Okay, the P is here. P is here. And the force is acting on this point, so the natural choice of the position vector is point P to this point. Okay, this is your R. Okay, and you have to figure out what's coordinate of this point the acting point, and what's the coordinate of this P, and then determine the vector. Okay, and determine the vector, and be careful because the vector direction is from point P to this point. Let's call it, I call it A. Okay, from point P to point A. So the vector, how to calculate the PA vector, you need the coordinate A minus coordinate P. Okay, be careful because it's P to the point A. So when you try to, so when you calculate the PA vector, it's coordinate of A minus coordinate of P. Okay, be careful because you cannot use the point P to minus point coordinate of P minus coordinate of A. You will get a very different answer. Okay, be careful. Vector has the directions. Okay, vector has direction. And the final simple example is this. Okay, also same thing. It give you the force vectors. Force vectors here, and point P is here. Point P is here. and what's the moment caused by the force with respect to the point P. Okay, the force is acting on this point, so natural choice for the position vector is here. Okay, this is R. Okay, and yeah, that's the same thing. If this point is A, also it's coordinate A minus coordinate P, because the vector now is in this direction. So the vector PA vector, you have to coordinate how to calculate PA vector, coordinate of A minus coordinate of P. And here is the coordinate X, Y, Z. He give you the information about the coordinate of point A and point P. So to calculate the PA vector. After you get a vector, just R cross F, you can determine the moment. Okay, so if these three problem, it's just let you know. Yeah, be careful about the position vector. Okay, if you choose the wrong position vector, you will have the different answers. Okay, because moment is R cross F, R cross F. If you don't have correct position vector, you will get a very different answers. Okay, so that's the moment calculation in 3D space. And okay, here's the I just stop a video here, and I think another thing else. Okay, the next video is for force decomposition. Okay, or maybe I just do the force decomposition in the next video. Okay, I'll stop video here. Okay. See you next time. Okay, bye bye.